Courses in the cement industry. Present to you. It will cover several episodes, answering the most important questions in the cement industry, whether it concerns production or mechanics. Important questions and answers for the cement industry. Part 2. Questions 1. What are the normally allowed hot rotary kiln, or drum shell maximum temperatures? Answer. Checking the specific construction material of your rotary vessel and the manufacturer's instructions. In general, we recommend that 400 degree is used as the maximum temperature. On this picture, the temperatures along the rotary kiln shell can be seen, which are measured by its scanner shell. Questions 2. During a rotary kiln warm-up, why is it important to control the temperature? Answer. Mechanically, there is a need to control the warm-up temperature, primarily, because all the heat being generated does not pass from the shell to the tire. This is the reason the tire is not directly connected to the shell on heated rotary vessels. If the shell heats too quickly, the expansion will not pass to the tire fast enough, and this can remove any allowed clearance and potentially crack the tire, or restrict the diameter of the shell in the area of the tire. The tire is designed to allow an amount of diametrical clearance to allow the shell to expand. This amount of clearance can also be calculated to allow a site-specific expected amount of error. The expansion rate of the shell must be controlled to allow the correct operating temperature to be reached and operated without incurring damage. Uneven thermal expansion will cause distortion and bending of the shell, which will damage the drive system, rollers, tires, and the mounting system and foundations. The warm-up time can be checked easily by monitoring the amount of slippage between the tire and shell during rotation at each tire station. Questions 3. What is skewing? Answer. Skew is the position of the roller axis with respect to turning axis of the shell. If the rollers are parallel, they have zero skew or are neutral. Zero skew means no axial thrust is created. If the rollers are not parallel, they are said to be skewed or cut. This creates an axial thrust that pushes the kiln either uphill or downhill. As kiln shells are not truly straight, the rotating axis at the rollers is not constant. Zero skew cannot be set with rollers that have a fixed base. This is only possible if the roller support base is allowed to articulate to follow the shell tire wobble. Skew is created with a very small, 0.1 to 1.0 mm, pivoting adjustment which changes the parallel relationship of the roller to the longitudinal axis of the rotating shell. It does not affect, to any significant degree, the position of the shell either in plan or elevation views. In other words, the roller is pivoted but the shell is not significantly raised or moved laterally. This important concept must be understood completely before correct roller adjustments can be made. Thrust control by skewing may be the single most important adjustment, which influences the optimum mechanical operation of the unit. Continue answering question 3, what is skewing? This important concept must be understood completely before correct roller adjustments can be made. Thrust control by skewing may be the single most important adjustment which influences the optimum mechanical operation of the unit. Learn more about skewing in this video. Once the roller shifts easily, use the roller reaction to guide adjustments. We will explain the skewing in detail in another video. Questions 4. Why do we need support roller skewing? Answer. Since the drum is set on a slope, gravity pulls it downhill. Therefore something must control the axial drum position. Typically this is the job of the thrust rollers. But the skew of the carrying rollers can also counteract this gravitational pull. Which means that requirement of most rotary kilns to have the downwards force reduced by support roller skewing. Rotary kilns which have a horizontal axis should not, in theory, require skewing if the all support rollers are parallel, and are also on the horizontal axis. However, in practice, a small amount of skewing is often required to allow the thrust rollers to be in partial contact with the tires during rotation. Only partial contact is desirable due to the small amount of misalignment which always exists on the tires. The optimum result is to achieve partial contact with the downhill thrust roller. However, it must be remembered that increases in rotational speed and load will increase the residual axial thrust. Questions 5. What is the most common cause of support roller spalling? Answer. Spalling is the damage caused to the surface of rollers under the weight of the rotary kiln. It starts when small surface cracks start to develop and grow together over time, eventually causing pieces of metal to fall from the surface of the rollers. The most common cause of support roller spalling is hydraulic compression. This is caused by the liquid used to lubricate the surfaces between the rolling surface of the tires and rollers at the point of contact. Liquids can also be introduced to the rolling surfaces by leakage of cooling water or spillage or excess from the lubrication applied to the bearings or associated equipment. Liquids are non-compressible. When forced through the rolling contact surface pinch point, the liquid pushes against the steel. This pressure can cause micro fissures in the steel, where droplets of liquid can become trapped and forced between the molecules of the rolling surface material. This fractures the steel on a microscopic level with every turn of the rotary kiln. Eventually, the cracks worsen and pieces of the roller surface fracture loose. Continue answering question 5. What is the most common cause of support roller spalling? As spalling can also be caused by various mechanical issues, it is important to identify the root cause of the spalling. If the spalling and its causes are not addressed, the consequences can be serious. Spalling can lead to extensive damage to the equipment, including failure of the tire, rollers, and bearings. The use of a dry lubricant, such as graphite blocks, to avoid the problems associated with spalling. Graphite blocks operating in contact with the rollers provide superior, compressible lubrication and allow for inspection during plant operation. Should resurfacing of the tire and rollers, to remove the damage caused by spalling using grinding system? Often, resurfacing can take place whilst the plant is in normal operation. Question 6. What causes mushrooming at the sides of the tires and support rollers? Answer. Mushrooming is a deformation due to high loading at the edges of the rollers or tires. This can be caused by over-skewing, rolling surfaces that are not flat, or problems relating to roller alignment. When the edges start to mushroom, the probability of cracks forming at the edges increases. Unless the mushroom shape is removed, cracking of the support roller or tire will occur. The causes of the mushroom wear pattern will need to be addressed to prevent the problem recurring. We can resurface the tire or roller by grinding, or, if the damage is extreme, by cutting away most of the mushroom and then grinding. Usually a reduction in the power consumption is also seen following these procedures. Question 7. Which is the best auxiliary drive system? Answer. The purpose of the auxiliary drive system is to prevent damage to your rotary equipment in situations where the machinery stops. It is an emergency backup system, and is not designed to keep production going. There are two main root causes of failure to consider. 1. Power supply. 2. Mechanical. In the case of power supply loss, the solution is relatively simple, and probably involves an auxiliary power supply, such as an electrical generator or diesel engine. If the failure is due to the mechanical drive, this indicates equipment failure and the resolution is more complex. Questions 8. What is causing the thrust roller to lift out of its bearing? Answer. The position of the thrust roller, in relation to the center point of the rotary kill, is critical to prevent lifting. The thrust roller must always be positioned slightly biased to the down-turning side of the kill. In this position, the rotation forces the thrust roller downwards. If the thrust roller position is slightly on the upturning side of the rotary kill, the rotation will tend to lift the roller. Recommends, the roller is positioned 1 to 2 mm on the down-turning side. We can determine the correct position required during our alignment measurements. It is not safe to move a thrust roller when the machine is in operation. Care should be taken when removing or replacing a roller, as the roller may lift out of the bearing, causing the parts to fall. Questions 9. Which is the best girth gear lubrication system to use? Answer. Recommends the use of constant loss spray lubrication systems, operating with dry lubricants such as suspended graphite or molybdenum, although named dry lubricants. These products contain liquid elements which act as carriers. As the spray is compressed in the mesh, the lubrication element builds a barrier between the gear and pinion. The lubricant is applied in the correct quantity, giving optimum life of the gear and pinion, with minimum cost of lubricant, and it allows visual inspection of the driving flank of the teeth. Questions 10. For the supporting roller, what is the approximate gap value between thrust ring and bearing liner? Answer. Both uphill and downhill bearing housings are keyed into the bases such that the space between the thrust buttons is 6 to 12 mm larger than the length of the shaft. This allows the roller to have that much axial float. When the roller is skewed to drive the shell slightly uphill, its reaction is to slide downhill. Questions 11. What is the cause of the horizontal lines appearing on the faces of the tires, support rollers, and thrust roller? Answer. These horizontal lines are usually caused by vibration coming from the drive gear and pinion mesh area. The vibration caused can usually be felt on the pinion bearings. The lines may be in sync with the tooth contact, or multiples of the tooth frequency. The causes can be 1. Reduced root clearance of the teeth, which will cause bottoming of the gears. 2. Loss of teeth profile. 3. Incorrect setup of the pinion and gear. 4. Incorrect design. The solution will be dependent on the root cause. Once corrected, grinding of the rolling surfaces is recommended. Questions 12. Is there a formula for determining the correlation between kill feed rate and kill speed? Answer. No, there is no precise formula for the relationship between kill speed and feed rate. This depends on the degree of preparation, calcination, of the feed at the kill inlet, and the progression of this feed preparation along the kill length. However, there are rules of thumb and guidelines you can use for various kill process types. What type of kill are you operating? Questions 13. We have a hot spot in the meter 22 on our kill. would it be possible to use a jet of water to cool the shell in this area? Answer. People sometimes do that. However, it causes a significant blemish on the shell, and when the water is switched on, a significant thermal shock, and potential contraction. In general, it is better to use fans and/or stop the kiln, and repair the refractory lining. If you put a fan close to the shell, you may induce the thin section of the lining to coat over and bring the shell temperature down. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.